All right, so I want to start off by refreshing your memory about some words that you can use in order to translate into inequalities. So first of all, in the top left corner, we have the greater than symbol. These words right here, will represent the greater than symbol, okay? These words will represent the greater than or equal to. These words represent less than. These words represent less than or equal to. So if you're having a trouble with a word and you're not sure which type of inequality to put in for that word, please come back and refer to this. So I would write this down first, and then we'll do some sample problems. Okay, so you will do these sample problems on your own note paper, and we're just going to go ahead and get started. We have this first word problem. You can work at most 20 hours. So the first thing I'm noticing, since it says at most, that means it's going to have to be less than or equal to 20 because I can't work any more than 20. 20 is the absolute most that I can work, okay? Then it says you need to earn at least $92. So at least, greater than or equal to, that means I need to make 92 or more, okay? So greater than or equal to $92 to cover your weekly expenses. So we have your dog walking job that pays $7.50 per hour, okay? And we have you working as a car wash attendant paying $6 per hour. And we're going to write the system and then go ahead and solve it by graphing. Okay, so if we call X your dog walking job, okay, and if we call Y your car wash job, this represents how many hours you're going to work in each of these fields, okay? So to write the inequality, well, I can work at my dog job and at my car washing job together, and I have to only work less than or equal to 20 hours, okay? So remember, X and Y represents dog walking hours, and Y represents your car wash hours, okay? And then in addition to that, I'm talking about money, so it's going to have to be a separate equation. In this case, a separate inequality. Well, the dog walking job is $7.50 per hour, so I have to multiply by the number of hours I'm working. And then the car wash job is $6 per hour times Y hours that I'm working there. Okay, and I have to make sure I'm getting greater than or equal to $92. Now, just like we did when we had equations, we're going to need to put this in slope-intercept form. So when I rearrange the first equation, I'm going to get Y is less than or equal to negative X plus 20. And that second one's going to look pretty ugly, okay? So we're going to start out by having Y is greater than or equal to negative 7.5 over 6x plus 15 and 1/3. Okay, well, it's definitely bad math to have a decimal in a fraction. So the way to get rid of that is to think about what that decimal represents. Okay, so I'm going to redo this decimal. It's saying that I have negative 7 and 5/10. So negative 7 and 5/10. Okay, well, I'm going to put that in an improper fraction. So I'm going to multiply 10 and 7 and get 70, and I'm going to add the 5. So I'm going to have 75, and remember this is a negative number. So negative 75 over 10, okay? But negative 7 and 5/10 is over 6, so I have to put that over 6, okay? All right, so we have to multiply by the reciprocal of 6. So remember that 6 is actually 6 over 1. So we have negative 75 over 10. I'm going to multiply by the reciprocal of 6. So I get negative 75 over 60. Well, both of these are divisible by 15. So that reduces to negative 5/4. Okay, so I'm going to rewrite this as Y is greater than or equal to negative 5/4 x plus 15 and 1/3. So Here's my first equation I need to graph. I've rearranged my second equation to use the one in the black box on the bottom, okay? So I would go ahead, and since we have larger numbers, go ahead and go by twos as far as your numbering on your graphs, okay? So I'm going to start with 2 on the x-axis, so 2, 4, 6, so on and so forth. And then as far as the y-axis as well, 2, 4, 6, 8, 10, so on and so forth. Go all the way up. And for the first equation, we're going to start at 20. So 12, 14, 16, 18, 20. Start there. And my slope is -1, so I'm going to go down 1 over 1. So it's going to be in the middle. Down 1 over 1 because we went by twos, remember. Down 1 over 1. Okay, and then go ahead and connect those dots. Okay, I'm just going to go through there. Okay, and since it's less than or equal to, I need a shade below. Okay, and then we have the second one. Now, I don't normally like mixed numbers, but in this case, since I'm trying to find a y-intercept, 15 1/3 is easier to find than if I had 46 thirds. Okay, so 15 1/3, I'm going to go ahead and get that one going. I'll put that one in green. 15 1/3, about right there on the y-axis, and I'm going to go down 5 to 10 1/3, and then I'm going to go right 4. So about right there. I'm going to do that again, go down 5 to 5 1/3, and go run over 4. Okay, so I'll have another one. That's right here, like so. Now, that says greater than or equal to, so I'm going to need to fill in above, which is all this, and my intersection of the two colors is where my final solution is, and it's actually in between the two lines right here, so I'm going to color it real nice and dark so I know where my final solution is. Okay? All right, so anything in there is a possible solution. You will need to denote one possible solution that you would like to find in there, and I'm going to go with 16, 1. 16, 1. That one. All right, so moving on to our second word problem. Make sure you have this written down. We have Marcia who's buying plants and soil for her garden. The soil costs $4 per bag and the plants cost $10 each. Okay, so if we say X is the soil bags and Y is the number of plants, then we can create our inequalities for that. Let's keep going, keep reading. She wants to buy at least 5 plants. Okay, so we have this at least. So remember, at least means greater than or equal to, so more or equal to 5 plants, and can spend no more, that means less than or equal to 100. That means she can spend 100 at the most, okay? And we need to write our system of linear inequalities. So, soil costs $4 per bag, so 4 times the number of bags, and then I'm also going to buy some plants, or Marcia is, however, plus 10 times the number of plants, and she can spend no more than 100, so less than or equal to 100. All right. Moving along, we want at least 5 plants. So Marcia wants at least 5 plants. So plants is the number of plants, Y, greater than or equal to 5. Okay. Only thing we need to do is put this first inequality in slope-intercept form. So I'm going to rewrite this. After I subtract the 4x over to the other side and divide by 10, I'm going to have y is less than or equal to negative 2/5 x plus 10. Okay, so these are the two that I'm going to end up graphing. So I can go ahead and label my axes by 1. So 1, 2, 3, 4, 5. And then up the y-axis, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Because I will need to start at 10 on my y-axis, okay? So if I do the first one, y is greater than or equal to 5, I need to find 5 on my y-axis. And it's going to be a solid line because it has an equal to, and it's greater than or equal to 5, so everything above it. All right, so I'm going to grab, I'll grab the red for the second one. Y is less than or equal to -2/5 x plus 10, so I'm going to start at 10, and I'm going to go down 2 and right 5, and down 2 and right 5, and so on and so forth. That one is also going to be a solid line. So I'm going to connect those like so. And it is less than or equal to, so that's going to be below the line. So everything below the line. And wherever these shaded areas intersect is our final solution. And all of those in there will satisfy both of the equations. So I'm going to make it really dark and noticeable. And I just need to choose some solutions. 1 is fine with me. It would be nice to have multiple. So if I choose 2, 7, that is an option of how many soil bags and plants.